Starting the chapter with the basic definition. So the definition of, we all know, since you have already done the second PU, correct? So, and you have just 1 month left. Still, I'm just prepping you up for the definition. We know that when left hand limit is equal to the right hand limit, and that is equal to a finite value, okay? And that is equal to a finite value, then we say that limit exists. What do we say? That the limit exists. When left hand limit is equal to right hand limit, and that is equal to a finite value, okay? Not an infinite value, then we say limit exists. And the limit at that point is known as the value k, okay? So pretty simple. I will be saying, so we still didn't get the feel of it. We didn't get the, what are you trying to say about the limit? Why we use it? Why do we need it? Okay. So let's see. Okay. What is the use? What is the need? Let's say we have a function. Okay. And in this function, the graph is going here. There is a what? There is no point in this graph. So for the value 2 here, okay, the function doesn't have any value in the y-axis. Now somebody wants to know, sir, for the value 2, for x equal to 2, what could the function would have obtained? Or what is the closest value near to that? There comes the limit part. Okay, whenever we want to know which is the value closest to it, or add to what is the approaching value we want to know that, then we use the term limit, or the approaching value, or the closed value. Okay, so what we do here, we define two terms. Okay, just like our neighbors, the right neighbors and the left neighbors. Here, let's say we talked about the right hand limit. So basically, right hand limit means what? When you are approaching this value from the right hand side. Now, is this what do you mean by approaching it from the right hand side? Right hand side means the values. Let's say here we have the values which are just slightly bigger than 2. The values which are just slightly bigger than 2, like 2 plus 0.000001. So how bigger it is? Just slight bigger than that. So if I'm able to see at 2, exact at 2, I don't know the value. But if I'm able to know the value at 2.00001, okay, then I'll be able to say that from the right hand side, when I approach the function at 2, I got a value which is almost near to 4. Correct. I got an approaching value which was almost near to 4. Okay. Now that only is known as right hand limit, RHL. Okay, and that means that limit x tends to 2 plus. Now this 2 plus means what, student? We are denoting a value which is just a bit, bigger than 2. Just a bit bigger than 2. Okay, don't confuse it. Okay, later we'll clarify what does 2 plus and 2 minus means in details. Okay, so it means that values which are just bigger than 2. Okay, now let's see then what will the left hand limit means. Left hand limit means the values which we are approaching from the left hand side. So for a value, let's say here at the number line 2, what is the nearest on the right hand side? 2.000001. And what is on this side, left side? 1.9999999. As many nines you can put. Okay. So this value is what? Very, very close to the 2. So we can say that we are approaching the function from what? From the left hand side. Correct. So when we are approaching the function from the left hand side, we call it as left hand limit. And that means that limit x tends to 2, and then top we have a minus. Don't confuse it with, sir, 2 power minus means what? It is 2 minus. Okay. It is minus 2. That is not the case, student. That is not the case. 2 minus denotes a value which is just smaller than 2. What is it? Just smaller than 2. Okay. Don't confuse with anything else. It means that we are approaching the function from this side, which is like just a bit smaller than 2. Okay. Clear? So that is the feel of it. When we say right hand limit, we try to find the value of the function for a values which is just bigger than 2. When we say left hand, we try to find the value of the function for the values which is just smaller than 2. That's it. Nothing more than that. The moment we know from the left hand side and from the right hand side, we are approaching it to value, let's say 4. So we can say that at 2, it can be like an approaching value towards 4. Okay. We don't say the exact value at 2 is 4. We say the limiting value for x equal to 2 is at 4. Okay. Is equal to 4. Clear? So we'll learn more about them in more details, and we'll see how we are using it. Okay, we'll learn more about them in details, and we'll see how we are using it. Okay, so let's see the next page. Now we have taken a graph. We wanted to get a more feel of it. Okay, so we have taken a graph, and what we have done, this is the graph of basically 1 by x square. So in this, what we have done is at 0 c student, if you approach from this side, correct? If you come from this side, what do you see? the function is almost going to what? Positive infinity. Now, if you come from the left hand side, okay, like values which are just smaller than 0. Just smaller than 0 means negative values. They are also going towards infinity. Yeah? Correct. So both the values, if you see the left hand value also is approaching towards infinity, the right side of value means 0 plus. Values just 0 plus means what? Values, it shows values just bigger than 0. Just bigger than 0. Correct. This means what? Values just smaller than 0. Okay. Nothing more than that. So this is also approaching infinity. This is also approaching infinity. Now the student will say, sir, the left hand limit, sir, is also approaching towards, and the right hand limit is also approaching both towards infinity. So can we say, sir, limit exists, sir? Correct. A lot of students will say, sir, yes, sir, limit exists, sir. You only told, sir, left hand limit equal to right hand limit, and that is equal to infinity. Students, my dear students, understand limit doesn't exist. Why? Because infinity is never same. See, for you, what is infinity? For me, what is infinity is entirely different. So infinity is not defined, students. Okay. So it has to be a finite value. Okay. Not infinite value. So that's why left hand limit is equal to infinity, and that is equal to right hand limit. These two are not equal. So we'll say limit doesn't exist. Correct. Okay. So limit doesn't exist. Okay. So very important that the left hand limit was equal to the right hand limit, but was not equal to a finite value. That's why we said the limit doesn't exist, and if it has to exist, it has to be finite. Very important. Okay. Coming to the next page. Now what we have done is, when we say limit extends to a minus, what do you mean by that? We mean that limit extends to a minus h, means a value which is just smaller than, what do you say, a. How we find it out? From a, subtract a value which is like very smaller, like this. Correct. Done. So that is h, almost tending towards 0. Correct. Now when we say a plus, means value which is just a bit bigger than a. Okay. So that is f of a plus h. So when we say 2, we are approaching limit extends to 2 plus. Correct. So 2 plus means what? 2 plus a value which is just bigger than 2. When we say 2 minus, so basically a value which is just bigger, no, smaller than 2. Okay. So that means, now if you see, limit extends to 2 minus, again I have informed you, is not equal to limit extends to minus 2. A lot of students, they will put minus 2 and they'll do the question illa, wrong. Fully wrong. Okay. There's a field. So basically we understood the limit. Whenever a function we're not able to find the exact value of a function, at 2 we use another methods, different methods to solve it, and that is like this limiting value method. We try to find where does the limit takes to, like where does the approaching value goes to. Okay, how near we can approach it to certain things. Okay, like if you think in a reality, let's say you want to go to your friend's house. Now you went to your friend's house. Now he didn't give you the exact address. So you asked him, like, give me some approximate address. Okay. So he's told, like, this place, some what do you say, gaming parlor is there. You can come to this. The moment you come to this, like, understand that my house is almost near in, like, what, 100-meter radius thing. Okay. Or like a 50-meter radius. Okay. So the moment you reach, you can understand, okay, I'm near to it. So limit doesn't give me the exact value, but it tells me the closeness of that value. Okay, how close we are, like a value which is very close to that exact value. So we'll be able to understand, we'll be able to use that what do you say, information in a much broader sense that we'll see in other parts. Okay, so as of now, this is the feel of the limits. How do we solve questions? How do we apply? Most of your KCET questions will be solved in less than 30 seconds by using LHOPITAL. A very few places we have to apply algebraic methods, factorization here and there, a bit rationalization, but most of the cases it will be done. Now next part, the most important part is we need to know the indeterminate forms. Now what are these forms? So these forms are nothing but the forms where we don't have an answer, okay? Where we don't know how to solve it, where we don't know how to proceed about it. Like whenever you are getting a numerator term 0 tending to 0, these are not exactly 0 by 0. Okay, a lot of students, they have a difficulty. This is, sir, this is exactly 0 by 0. Illa. This is not exactly 0 by 0. Exactly 0 by 0 is not defined, students. Okay, this is approaching to my top. The numerator limit is tending to 0 and the denominator limit is tending to 0. Okay, so mostly in KCET you will get these two kinds, either 0 by 0 or infinity by infinity form, okay? And most of them, both of them, you can solve it by our favorite method, L'Hopital, okay? L'Hopital, nothing more than that. What is L'Hopital? We'll see. Other methods, infinity minus infinity. So it's also very big term, it's also very big. But who will dominate? Which infinity will dominate? We don't know. So it is again indeterminate. Infinity method 0. Infinity and 0. Okay. See, infinity has a power when you multiply infinity with something, it makes it infinite. And 0 has a power when you multiply something with 0, it makes him a loser or a 0. So who will dominate? A winner or a loser? Let's see. So that's why we're not able to decide. So we kept in an indeterminate form. 0 power 0, infinity power 0, 1 power infinity, same thing. So these are the 7 indeterminate forms, okay, which are very important to know. And whenever we see a question like this, we need to know the ways how to solve it. Now for J and all that part, we have separate ways for all of them to solve it, okay, how to convert it and solve it. For KCT, we'll be just seeing most of these questions, okay. So don't worry, these are pretty simple questions, okay. Now let's talk about algebra of limits, some formulas, okay. Let's say we have two functions, plus and minus between them, and limit is outside. So what you can do? We can take the limit inside, we can solve the first function, use the limit, solve the second function, use the limit, and then add or subtract, okay. This simple thing means limit, let's say, x tends to a, we have, let's say, sin x, plus here we have cos x. So what you can do? Separately, you can first solve limit x tends to a, sin x, and plus limit x tends to a, cos x. Once you solve these two, then you can add. So pretty simple. Now if some constant is there, so multiplied, you just take it out, solve the limit first and do it. Okay, like limit 2 cos, limit x tends to 2, okay, 2 cos x. So what you can do, just take 2 out, limit x tends to 2 cos x, okay. So here cos 2, yeah, you can take it. So you solve this limit and then put the 2, okay. Now, what is the multiplication? Again, same thing, okay. Not going in much details and depth, but same thing, students. If you have any doubt, put it on the comment section. Take a screenshot of this, okay. Now, one doubt student had one of the videos, the audio was not synced, so we are trying to re-upload it. If we have an option, we'll edit it. If not, we'll re-upload it. Do watch it out. The PO, what do you say, physics, electric charges and field, second part. So we'll be putting it like within around, you can say, 2 hours to 3 hours, within 2 to 3 hours span, we'll put that video, okay. Thanks for bringing it to the notice. Okay, now let's see a function fx by gx. So here again directly we can use the limit on the numerator separately, denominator separately, nothing is there, okay. Just take care that whatever is there in the denominator should not be equal to 0, correct? So the values of that for which the denominator becomes 0, we have to remove it, okay. Now, what if log, sir? So log will affect, no, log also won't affect. So log you take it out, limit you put it inside, solve it and then use the log, okay. Pretty simple. Mod also same thing. Insert the limit inside, solve the limit first, then use the mod. Pretty simple questions, pretty simple formula. Stop the video here, write down all the formulas, move ahead, okay. Come to the next page. Now let's see some standard results, okay. Now let's see some standard results. Limit x tends to a, x power n minus a power n whole divided by x minus a. Now you need to understand whenever you see something like this, okay, here x, here a, here x, here a, power is 1, 1, here is n, okay, and it tends to a, so it will be nothing but n into a power n minus 1, that's it. So I've taken an example, let's say limit x tends to 2, x power 10 minus 1024. Well, so sir, 1024, I don't know, sir, what is it? It's 2 power 10, kids, okay. So you need to know a few of the stuff, okay. So x power 10 minus 2 power 10 by x minus 2, so directly you can write 10 into, what is the formula? 2 power 10 minus 1, so what is it? 2 power 9 is how much? 512, and into 10 is what? 5120, okay. Done. Now coming to limit x tends to 0, 1 plus x whole power n minus 1 divided by x, that is equal to n. Use it, you will get the answer. Simple question, nothing is there, okay. So you need to know how to use the formula. So I'm not going, student, again understand, we have very less time. We are trying to bring everything by 10th only, okay. We are trying our best to bring everything by 10th. So the derivative parts, the, what do you say, derivations which are not there for the KCT, we won't be able to go in much details and depth about that. Don't worry, we'll be launching a series for second PU very soon. Okay, for the students who are for the upcoming second PU, you'll be launching a course very soon. So don't worry about that. We'll go in depth. We'll talk about in depth on that. But in this video, we'll be just more focused on how to get your marks above 50 plus in the KCET. So follow us very dedicatedly, understand everything. We'll try and give you everything by 10:30 I promised, okay? So let's see. Now some important results, okay? Trigger results are, you need to mug up, okay? Or you need to keep in mind so that you can be fast. Limit x tends to 0 sin x by x, always done, okay? And if it is opposite x by x, x by sin x, then also same thing. Same thing, tan x by x is equal to 1. X by tan x also same one, okay? Inverse formula, mug up madi, okay? Sin inverse x by x, same one. X tends to 0 cos x equal to 1, okay? We can show you the proof, but it's not needed. Now, sometimes they don't give you directly, but what they'll do, they'll take the limit x tends to, let's say, a, or like, let's take 5. And they'll give you what? Sine of x minus 5 by x minus 5. Same thing. If I put 5, it is sine 0 by 0. So that is equal to 1 again, same thing, okay? So same thing with the tan, okay? Same thing, limits the x tends to, when it is infinity, it will tend to 0, okay? Clear? Now, same thing with cos x by x. Now, limit x tends to 0, 1 minus cos x by x is also again 0. This formula is important for KCET. Important for KCET. Okay. These formulas are important. This is important. Okay. This part is important. This is important. Okay. Then, what do you say? This part is also important, like for the KCET part. And this part is also important. So, these are the important for the KCET part. Okay. Now, one formula of log, this one is important, students, you can go through. Okay, I've given a lot of formulas. Okay, this part also is important, but not that much, but this is more important. Okay, then this all can be done by L'Hopital. When I'll teach you L'Hopital, like pretty simple, nothing is there. Okay, so you'll be chill about it, don't worry about that. Okay, so this again, see, when it is plus 6 here, so plus 1. When it is minus 6 here, so minus 1. If you differentiate money, you'll get it. Okay, nothing is there. Now, this part important for KCET, but very rare questions have came, like one question max, but still, okay, it's important. But do write it down, okay, and do mark up the formula whenever you have in the form of fx power gx, okay. So it will be e limit x tends to a, just like integrating factor ones, okay, gx into log of f of x, okay. So the proof and all I'm not showing you as of much, so okay, no need. Exponential, whenever it is a power x minus 1 by x, so it is log a. So any example? Yeah, very simple example. Limit x tends to 0. So 2 power x minus 1 by 2. So that is equal to log 2 basic. Correct, that's it done. Coming to this same thing, whenever it is e. So e power x minus 1, just like it was log 2. So here it will be log e base e. So log e base e is how much? 1. Correct. So done. Now 1 by infinity form, a few times we have seen questions like that. 1 plus, either you will get fx and then power 1 by gx, or you will get fx power gx. Okay, here fx, then power gx. So in both the case, we need to multiply these two. In both the case, what you have to do, take e, limit x tends to a, then multiply these two, fx into 1 by gx or fx into gx. And then you'll solve it, you'll get the answer. Nothing more than that is there. This is important, okay. This is important formula for KCET. In the application part, I'll show how to apply. Okay, in the application part, I'll show you how to apply. Till then, just the formulas go through. Nothing is there, student. Much, okay? So don't worry about that. Now, one example we have taken, limit x tends to 0. So it is what? 1 plus 0 means 1 plus x tends to 0. So 1 plus 0 means 1. 1 power 1 by 0 means what? Infinity. So it is basically of the form what? 1 power infinity. That is equal to what? E. So same thing, limit x tends to infinity. And if I put 1 plus 1 by infinity power x, that is equal to e. So same thing both, okay. If I have a lambda here, so that lambda will come into e power lambda, nothing more than that, okay. Earlier I had just takes this lambda and e power lambda, nothing more than that. If it is 1 by lambda also same thing, okay. So don't worry, it's exactly the same thing, I just took common. So 1 by x also this same part, we need to multiply. This and this will be cancelled. If I multiply this and this cancel, like e power lambda will be there, that's it, okay. Here also we are multiplying these two on the power of e. So that got cancelled. So e power 1 came, e power x into 1 by x. Correct. So we got e, here e power lambda x into 1 by x. So we are getting e power lambda, or e power, what is it? Lambda by x into x. Same thing, I just change it. It's e power lambda. Okay. Nothing more, just formulas you go through, it will be done. Now, the most important and the most awaited one, the L'Hopital. Okay. Understand, very important. Where to apply, when to apply, and how to apply. all three, most important for L'Hopital, to solve almost 99% of all your questions in KCET limits part, L'Hopital is the best solution. What is L'Hopital? Where we can apply? Let's see it. So limit extends to a, we have in the term of fx by g, numerator by denominator. If they are of the form, 0 by 0, means tending to 0, or infinity by infinity, or infinity by infinity, these two forms 0 by 0, or infinity by infinity, say it out loud, okay, while watching the video only. So 0 by 0 or infinity by infinity, what do you do? Differentiate money, okay, what do you do? Differentiate numerator separately, denominator separately, till they come out of the 0 by 0 or infinity by infinity form. So what do you have to do? One time you differentiated f dash x by g dash x. Now again you are getting 0 by 0 form or infinity by infinity. Again differentiated. So f double dash x you did by g double dash x. And if you got the answer, well and good, balle balle. If you didn't get the answer, again differentiate. Okay, separately, kid. Okay, don't do quotient rule. Okay, clear? That's it. So nothing is there. Whenever you are getting any function in the form of numerator by denominator, fx by gx, when you're getting any function in the form of fx by gx, and that is equal to 0 by 0 or infinity by infinity form, directly close your eyes and differentiate. Okay, once you differentiate it, check. Okay, a lot of students, what they do, they differentiated and it was looking a very simple differentiation, they again differentiated. Don't do that. Once you differentiate, put the limiting value, check it again, is it in the form of 0 by 0 or infinity by infinity. Disclaimer, okay. So what is the disclaimer, okay? So the disclaimer is once differentiated, check mari, okay? Check it. So once differentiate, check it. If it is coming again in the form of 0 by 0 or infinity by infinity, then do again. Otherwise, put the values, get the answer, go home. Pretty chill. That's it. Nothing more than that in L'Hopital, okay? Now let's see. Few tips and tricks, a lot of videos, a lot of YouTube. You'll see a lot of tips and tricks is there. There's nothing but basic formulas, and then they have used as a tip tips and tricks. Okay, I'll just give you the same thing, but we won't be having that much of time to explain everything. But you can use them. Okay, whenever you see 1 minus cos mx by 1 minus cos nx, directly you can write m square by n square. Okay, directly you can write m square by n square. You can take an example. 1 minus cos 2x by 1 minus cos 3x. Okay, so directly this you can write by 4 by 9. That's it, answer. Clear, huh? How do we get it? Cos 2x, you can expand it to cos square x minus 1. This is very important formula, okay? Or 1 minus 2 sin square x or cos square x minus sin square x. So cos mx can be written as what? Cos mx can be written as 1 minus 2 sin square mx by 2. Okay, from here only, and then we use the formula of sin x by x1. Okay, so we'll get the answer. Proof, I'm not showing it right now, don't worry. Later I'll show you, okay? Limit extends to 0, cos ax minus cos bx by cos cx minus cos dx. It will be what? A square minus b square by c square minus d square. That's it, okay? Directly you can put the value. Again, cos mx minus cos nx you have taken. So it will be, what do you say? N square minus m square, done. Next, now we have some function like sin 2x and then power is 5 by sin 6x power is 5. So what you can do, 2 by 6 whole power 5. Directly you can use this formula, okay? These are the shortcut tricks. You can use it. But understand the concept, most of them, you can solve it by L'Hopital, okay? Again, one more, just I'm giving you the formula, okay? So limit extends to 0, you won't use it much, okay? 1 plus ax by whole power b by x. So you do it same thing in case this, it will be e power ab. Just like alpha was there, no, it was e power b, ab. So basically understand the concept. So what you do, you're doing e and then whatever is here you multiply money, okay? Ax into b by x. So what are you getting? X went home, so e power ab, okay? Same thing we did earlier also. Clear, here also you say, sir, I'm multiplying, just I'm multiplying. E power a by x into bx, okay? So x went home, e power ab, clear? Now this formula, use it, you won't be needing much. X power n by y power n whole power 1 by n is equal to y, that's it, okay? So almost every formula, what you will be needing for KCET and even extra, which you won't be needing, I've given you in this formula plus concept video. I explained you what is limit. I gave you all the formulas which you will be needing it, and almost 99.9% of the questions you can solve by using L'Hopital in KCET. Okay, otherwise you by definition only it will be done. So you don't have to worry much about all the formulas. So go through just for your knowledge, we gave everything also. So you don't have to worry. Okay. So next part will be solving the PYQs. Okay. So let's see. Oh, one more thing. This is the limits part done. Now a bit we'll discuss about derivations or derivability. Okay. What is derivatives? What do you mean by f dash c? Okay. Or d of fc? Or what do you mean by d by dx of fx? Correct. We write no f dash x. What do you mean by that? So that means that it is the limit part of limit. Limit extends to c where fx minus fc by we are doing by x minus c. Okay. Provided that all limit exists. So what is d by dx? D by dx is nothing but limiting value at c for f or the function fx minus fc by x minus c. So that is known as f dash c. Correct. So this we should know it. Okay. Now let's see the other parts of derivatives. A bit few. What is the physical interpretation? Okay. Let's say you are a point here and you are running. Okay. So when you are running, okay, or you are covering a distance, your distance we are getting by a function f of t. So when I differentiate this f of t, when I differentiate distance, what I get? Distance. Speed, correct now. So what is the speed? Speed is nothing but speed or instant speed of person is nothing but the derivative of d by dx of that distance, correct? Distance function f of t. So basically the interpretation of physical interpretation is if we have a function ft which is showing a distance, then derivative of that function will be given by a instantaneous speed of the person. Okay. Let's see the geometrical part. Now the geometrical interpretation is if we have a curve like this, okay, you draw a tangent, okay, we'll be doing this in AOD, don't worry. So we have a function y is equal to fx. When we do differentiative, basically it gives the slope of the tangent at that point. What it gives? Slope of the tangent at that point. So basically geometrical meaning was draw a tangent, its slope is given by derivative of that function. That's it. Okay, nothing more than that. Now a few important formulas we already know. F dash x is nothing but limit h tends to 0, f of x plus h minus f of x by h. That's it. Okay, we know the what do you say, plus and minus, so you can just differentiate separately. We know UV rule, correct? Differentiate the first function, leave the second as it is. Differentiate the second function, leave the first as it is. So u dash v plus v dash u, everybody knows that, correct? And what is the derivative of u by v? First function you differentiate mari, second you leave it. Second you minus, second you differentiate mari. First, what do you say? First you leave it by second square or denominator square, correct? Done, that's it. Okay. So this is the full concept plus formulas of limits and derivatives.